is less water in the air than 100% humidity in warm air. And you all notice this, because when it's 100% humidity in the summertime, you just feel like you're walking through water, almost, because it's like you just sit still and the water's just collecting on your skin as sweat, right? That's because the hot air can hold more water. And I would think for the eczema, the more water in the air can help. Less water in the air would dry you out. So move to Boca Raton. That's my advice.
What? What's an easy class? We did?
Yeah, I told you.
Okay.
I love it.
I should probably just say single.
I'll grab a question on that one. I don't make sense.
So last night, I assigned problems from 60. Questions? Yep. Number 16, this is a graph of a sine. Oh, but they want them in terms of cosine. So write equation in terms of cosine function.
I really don't understand these.
Top 10, bottom -20. The middle is going to be in between those, that's a gap of 30. So top and bottom is going to be a gap of what, 15 for the amplitude. Let me draw this guy here. Looks like that. Now you can tell just from this picture that the cosine graph has been shifted some. Because where do you expect the cosine graph to start? Yeah, at the top, like up here. So we expect it to start here. Well, based on that, we can see how much our shift is. Because on the graph, if you look at the picture, that's at 45 degrees. So in other words, our graph has been shifted right 45 degrees. So we're not dealing with a cosine graph, we're dealing with a cosine x minus 45 degrees graph. Does that make sense? How tall are the peaks? Well, the total height of the graph is 30. So each peak is going to be up 15 and down 15. Does that make sense? So you can see where the center line is, because if you go up 15 from -20 and down 15 from 10, you're going to be at -5. Does that make sense? So it's a cosine graph that's been stretched, that's by a multiplier. It's been shifted down 5 units, because the center line is normally at 0. That down 5 is just a -5 at the end. And it's also been shifted to the right 45 degrees. The only other thing to check is period. And if you go from peak to peak, you can measure that. And over here, that next peak is at 405. So to go from peak to peak, that'll give you a measure of period. And the period, 405 minus 45, 360. So we have a period of 360. That's what we want, right? That's the normal period. So if the period is 360, that means no multiplier on our x term. Because when the period is off of 360 is when we have to introduce the multiplier. So let's put all this information together. Amplitude, that's the multiplier at the beginning. So we have y equals 15. Cosine, not cosine x, because we've been shifted. So we're going to plug in x minus 45 degrees. And we've also been shifted vertically. The center line is not at 0, the center line is down at 5. So we'll go -5. I'm trying to remember here how this works. Sometimes you'll see this written as a cosine x minus h degrees plus or minus c. Sometimes you'll see it written as that, where amplitude, cosine, horizontal shift, H for horizontal, and C for center line. Sometimes you'll see it written like that. So the A reminds you of the amplitude and the C reminds you of the center line. Sometimes you'll see it written like this too. When you have a multiplier on your x, this is what affects the period. Each time the k goes up, it's going to get you around the unit circle quicker. But for this particular problem, here's our answer right there. 15 is the stretch of the amplitude, 5 is the shift down, 45 is the shift right. No shift in period. The period's still 360. I think the traits, because we've listed this before, the traits you can say whether it's positive or negative, whether it's sine or cosine, what the horizontal shift is, what the vertical shift is, where the center line is at. Actually, that's the vertical shift. And the amplitude. And the period. Those are the characteristics. The graph is either positive or negative, sine or cosine. It could be horizontally shifted, vertically shifted, that's going to affect the center line, the vertical shift. The amplitude, how much it's stretched, this is the multiplier in front of the sine or the cosine. And the period is going to be the multiplier on the angle. Those are the effects. Those are the characteristics that we're looking for. And you should be able to find the 6 things on the graph. Cosine graph, positive cosine graph, shifted horizontally, shifted vertically, amplitude of 15, period of 360. I do agree there's a lot to look at, but it's all there. Does that help some? Kind of. Get more practice if it's something that's you're less familiar with. So I'm thinking that maybe next week or the week after we'll be in a position to take another quiz or test. So be prepared for this kind of stuff is going to be on full display, because this is the extent of it. When I say this is it, this is really it. That's the extent of what you can work with these graphs. But you got to have all that down. And I know that every time I assign 2 problems, one of them's odd, so you can always fish in the back and get the answer, and then only have to do one, which you can always ask me the question for in class, and then your homework will be fine. But to know it for the test is going to be a different story. Any other questions? Okay.
Wait, I have a question with that.
Yeah.
Number 11.
Number 11. Two log 2 of x minus log 2 of x minus a half equals log 3 of 3. Sadly, the logs are not with the same base throughout, but we'll be able to work through that. Here, we can bring the power up, and then we can divide.
Oh.
I know the chalk fragments, excuse me. Log base 2 of x squared over x minus a half equals. That's a really tiny piece of chalk, I know. Now normally when you have logs on both sides, you have the same logs. But in this case, we have a log 3 of 3. That's actually kind of easy to work with. That is 1, exactly, good. So then we have only logs on the one side, which you can, if the log's only on one side, you can always use the exponent to undo. 2 to the first power equals x squared over x minus a half. You can write that 2 as 2 over 1, cross multiply. X squared equals 2x minus 1. I feel crippled. Little pieces of chalk. Grab the biggest piece I can find. So x squared equals 2x minus 1. You can solve that out. X squared minus 2x plus 1 equals 0. And then you'll get x minus 1, x minus 1. In other words, x equals 1.
Okay, seems a good one.
And that's a valid number because when you plug 1 in, you'll get a positive number. When you plug 1 in, you get a positive number. And you need to get a positive number because 2 to any power is positive. Any number of multiples of 2 will always give you a positive number, never give you a negative number. And we have to be cautious to check because they throw problems in now where the answers might have to be rejected because they're false answers.
Awesome.
Yeah, yeah, I know, right? Yeah, I feel the same way. It's an extra bit of hassle, really.
Oh, yeah, on physics. I got negative time.
Yeah, negative time, right? That's exactly
That
right.
quiz that we had where like the entire first page was unsolvable, remember that?
No, I don't.
You had to give us like a new mark and we got on the test and we were all like, Mr. Black, first page is unsolvable. We
Gosh.
were getting like I for like time or distance or something.
Yeah.
I remember the test I cried. I
I cried. I was like,
I,
what?
that was, I don't remember that, but I'm sure it happened.
Basic math.
It was funny.
And yeah, we were getting eyes for time, so that's
All
fine.
my answers are all 5 points. And you basic math. I did the same thing.
Yeah, I did the exact same thing.
Dang.
And did you do the, did we just do the exact same thing?
Why are you copying me?
We.
Oh,
This
wait.
copy says smart.
You didn't collect my homework this again?
Oh, I didn't collect your homework?
Yeah.
That's a
Wait, did you
mistake.
do that too?
Thanks.
But I did the same thing.
What happened here? Did you?
I got perfect.
Oh What did we all do?
Oh, apparently it's 30 degrees. Not a 60 degrees. Did we all put a 60 degree angle?
Except for the
I did.
Yeah.
Oh, yeah, that makes sense. because-
It does make sense.
Because tangent is opposite of tangent.
We all just forgot how to do basic trig.
it's okay.
It's okay.
That's half the reasons why I have backwards motions. I have to basic math.
Okay, let's get back to talks about normal curves. Now, if you at any time yesterday were thinking, oh gosh, another thing that you're never going to see again, absolutely wrong. This is something you will definitely see again. This is something that you encounter all the time. This is something that you just get used to by being alive, because you're constantly around randomness. And randomness comes in all kinds. Although, generally, when things are random, there's a lot of behavior around the middle, and then a little behavior on the fringes. That's the way it goes. Right? I mean, think about that. Even as you hear me say that, you're like, oh yeah, that makes sense. Now, the middle of the graph is the mean, and we can go a certain amount from the mean. That certain amount that we move is called a standard deviation. So we can move 1 standard deviation from the mean to the right, or jump 2 standard deviations. And we could do the same in the opposite direction. And we'd be catching a symmetric part of the graph. The normal curve is a symmetric curve. It's symmetric because flipping a coin is just as likely to have low heads as high heads. This curve is generated from just repeatedly flipping coins. When the coin flips approach infinity, the curve of the frequency of heads versus tails will make this normal. Few trials will have low numbers of heads. Many trials will have middle number of heads, and few trials will have high number of heads. Most of the trials will have about 50-50. That's the way it works. Now, we said 34% of the data lies within 1 standard deviation in each direction, which means together, 68% of the data is within 1 standard deviation. Go within 1 standard deviation, you're going to find 68% of the data. 2 standard deviations is going to grab 95% of the data. That's an additional 13.5% in each tail. The little tails that lie on the end are 2.5% each. That's the additional 5% that's not accounted for in the 95% that's found within 2 standard deviations. Why, again, why is this important? How many things are affected by random chance? A lot of things. One thing is genetics. As genes get passed on, bell curve, height, weight, hair color. Like how much pigment you have in your hair, bell curve. Few people with a little pigment, few people with a lot of pigment, lots of people with medium amounts of pigment. Lots of people have brown hair, not a lot of people have black hair, not a lot of people have blonde hair. That's the way it goes. Genes, random. Height, random. Test scores, random. Now, how do you compute a standard deviation? Remember we did this last time? The standard deviation is the square root of the sum of each number minus the mean squared over the number of numbers. Let's do another standard deviation calculation just to get familiar with it, because we did it yesterday, we went through it once. Let's do it again, it'll get us familiar. So let's find the standard deviation of 3, 4, 5, 7, 8, 8. That's a set of numbers. And we can come up with the standard deviation for that set of numbers. To do the standard deviation, we're going to have to know how many numbers we have, what the mean is, and how far each number is off the mean. So as a first step, let's calculate the mean. The mean is calculated by adding up all the numbers and dividing by the number of numbers. This is a good old-fashioned average. Add the numbers up, divide by 6 in this case. So what, 3 and 4 is 7, 7 and 5 is 12, 12 and 7 is 19.
27 and 35.
Thank you. 35 divided by 6. Oh, that's fun. 5.83 repeating.
Yep.
Yay. We'll say 5.83 just for the sake of sanity. Now, let's look at our numbers. This column we'll call X for our numbers. Our numbers are 3, 4, 5, 7, 8, and 8. Next column. Look at your numbers minus the mean. This is going to show you how far your number is off the mean. 3 minus 5.83, negative 2.83. In other words, 3 is negative 2.83 below the mean. 4, negative 1.83. 5, negative 0.83. 7 minus 5.83 is 1.17. 8 minus 5.83 is 2.17. In other words, this is showing you how far above the mean and how far below the mean the numbers are. When you add up this column, you always get 0. If you added up this column, you'd always get 0. That's what the mean is. It takes all the numbers and finds the point that's smack dab in the middle, where some of the numbers are below and some of the numbers are above, and the amount that the numbers below are below and the amount that the numbers above are always equal. That's what an average does. An average makes sure this column adds to 0. Always. You're always going to get 0. If you don't get 0, you screwed up. But what do we care about with our standard deviation? The sum of the squares. So, in our third column, we can put x minus mu squared. This is where a calculator is going to help out a lot. So, we'll take 2.83 times itself. And I'll just round to 2 decimal places. 8.01, 1.83 times itself, 3.35, 0.83 times itself, 0.69, 1.17 times itself, 1.37, 2.17 times itself, 4.71. Now this is the column we care about, the sum of the squares. 8.01 plus 3.35 plus 0.69 plus 1.37 plus 4.71 plus 4.71 over. Isn't that fun when you make a mistake? I won't count it. Doesn't have a weight, but 37 plus 22.84. What is this number? This number is the sum of all the squares. So what are we supposed to do with that number? We're supposed to then divide by the number of numbers and take the square root. So 22.84 divided by 6 square root. That's going to give us our standard deviation. The sum of the squares divided by the number of numbers. 2.84 divided by, or 22.84 divided by 6, we get the square root of 3.81, and that is 1.95. Game over. There's our standard deviation. That means, for this information, look at our mean, and look at our standard deviation. We can make a bell curve. Sometimes they ask you to describe the data if normally distributed. Think of it as a normal curve. What's the middle of the normal curve? The mean, 5.83. That's the mean. Go one standard deviation to the right. 5.83 plus 1.95. Because the standard deviation is 1.95. 7.78 is mu plus 1 standard deviation. You expect 34% of the data to lie between 5.83 and 7.78, based on the numbers that we got. Most of the data is going to be less than 7.78. Very little of the data is going to be above 7.78. Go 2 standard deviations, add another 1.95. Now you're going to be up to 9.73. This is mu plus 2 standard deviations. You only expect about 2.5% of the data to be above that, with 13.5% of the data in the tail line. Before I write anything else up on the board, just take a moment and absorb that. Based on the information we got, the data is going to be centered around 5.83, and above 9.7, you're only going to get that very occasionally. Look at the numbers. They were between 3 and 8. What it's saying is, if this is a random sample of the data, then getting somebody with a score of 9.7 is going to be unusual. Yeah, unusual, because the data was between 3 and 8. Go backwards, take a standard deviation away. So start at the mean, 5.83, and subtract a standard deviation. 5.83 minus 1.95. 3.88. This is mu minus 1 standard deviation. Take away another standard deviation. Minus 1.95. You're going to be at 1.93. This is mu minus 2 standard deviation. You expect very little data, less than 1.93. Look at the data you got. If that data you got is an actual random sample of the data, then indeed, numbers less than 2 would be strange. Numbers greater than 10, also unusual, because the data came between 3 and 8. Most of the data you expect between 4 and 8. Yes, indeed. Most of the data you expect between 3.88 and 7.78. And it is, in fact. Most of the data is in that range. So if you're going to describe the data, one way that you can describe this is you could say 68% of the data is between 3.88 and 7.78. Because 68% of the data lies within that first standard deviation. Within 2 standard deviations, 95% of the data, 95% of the data is gonna be between 1.93 and 9.73. When they ask you to describe the data, that's what they're looking for. To say 68% of the data is gonna be in this range, between 3.88 and 7.78, and 95% of the data is gonna be between 1.93 and 9.73. When I curve your tests, I've curved tests only on occasion, but whenever I do curve your tests, I look at the average, I look at the standard deviation, and I go 2 standard deviations out, and that's where I make 100%. Sometimes people score above 100%. If they did, what that tells me is, based on the distribution of the students, these students did extraordinarily well. Sometimes those numbers come out as, sometimes people get 115, 120, 100 and whatever percent. Well, that's because they did, based on where the averages were, exceptionally well. And I always cut that as 100%. That's how I do all my averages, or all my curves. Find the mean, find the standard deviation, and plug it out. Figure out what's 2 standard deviations away. Say, that's a really good score. You don't expect many people to do better than that. Call that 100%. If you did do better, you're one of these rare birds that happen to have scored in that tail, but most people should be less than. Just for reference. Okay, at this point, I think that's all we can do. If you ever see in a problem, let me just point out a couple things first. We talked about mean. We talked about standard deviation. A couple other statistical terms that you probably have seen before, but I just want to make sure that we have unlocked. Mode. Mode refers to the most common number. So if they ever ask you for the mode, look at the numbers and look at which one appears most often. In the case above, the mode is 8. If you had a set of data like this, this has 2 modes. That's got a mode of 4 and a mode of 8, because the most common number is 4 and 8. If you had data like this, there's no mode. If every number appears exactly once, no mode. Because if you resurrected any of the numbers as the mode, you're going to have to resurrect all the numbers as the mode. And that would be silly, right? You don't want to say that every number is the most common. If you're ever in a case where every number only appears once, you say no mode. If you're in a case where there's a tie, there's 2 modes. The modes would be 4 and 8 in the case above. In the case where you only have one number that obviously occurs most often, he is the mode. So in the numbers that we got, the mode is 8. Questions on mode? Median is another term. So when you list the terms from smallest to largest, it's the one right in the middle. That's what the median is. The median is the middle number. So to find the median, what you do is you start crossing out numbers on each side, one by one. So you cross off the extreme, cross off another set of extremes. And if you're ever left with 2 numbers, you find what's smack dab in between them. So what's smack dab between 5 and 7? 6, right? If you had a combination of numbers that was difficult to find the middle, you just average them. 5 plus 13 is 18 divided by 2, 9. 9 smack dab in the middle. It's 4 from 5 and 4 from 13. So 9 would be the median in this case. Here the median is 6. In a case like this, 5.5. If you had a case like this, cross off first and last, cross off first and last. If you only have one number, he is the middle number. So here the median is 5. Questions on median? The last thing you'd see, possibly, is variance. Variance is the number that you take the square root of to find the standard deviation. The variance is equal to the standard deviation squared, in other words. So in this case, the variance would be 3.81. It's basically the number that you take the square root of to find the standard deviation. If you're ever asked that, now you know. Mean, median, mode, standard deviation, and variance. 5 statistical measures. If this is exciting to you, statistics, think about it. If this is not exciting,